Good morning, class. If you are still having problems with drawing resonance structures, I would like to strongly recommend that you watch the following video. I put together some problems that will help you to be able to get a better grasp on drawing resonance forms. Okay, the most important thing is to recognize patterns. As you can see here, this is a pattern involving a positive charge next to a pi bond, which we call an allelic cation. That means we can delocalize it. And if you delocalize it, what you're going to obtain will be something like this. See? Then you can delocalize it again because it's still an allelic cation, and you get this. Okay, now if I put in the arrows, which will be the right thing to do, so you can go like that, then you can go like this, and you get that. Now the next one, as you can see here, is an allelic lone pair. See, we have an allelic lone pair, so we can delocalize that. We can delocalize it to give us, see, and we get this. See, so again we can move. Notice that the arrow always begins either at the lone pair and ends on the bond, on the sigma bond, right, or on the pi bond and ends on the atom. Okay, now that is how we normally delocalize. Now in this example here, we can recognize two patterns. We can recognize two electronegative atoms with a pi bond between two electronegative atoms with one being more electronegative. So we can easily draw the first one, whereby we move the electrons that make up the pi bond, right? We have a positive charge there. Then we can move. Then we see another pattern. We see a positive charge next to an atom that bears a lone pair, so we can move that as well. Oxygen there. So again, we can move that like this. As you can see, we get this. Then we move that like this, and we get that. And of course, if you want to go back to where you started, all you need to do is move that and move that like that. Now, the next pattern. The next pattern is we have an allelic lone pair. So we can delocalize all this. I'm going to have to change my pen to blue, back to blue. So we delocalize, put the oxygen. The oxygen now has a positive formal charge because it has a double bond. And this will be negative, like that. Then we can delocalize it one more time. Right? And then we can delocalize it one more time. And then delocalize it one more time. So Move this like this, like that. You can move this down like this, like that. You can move this down, this like that. Then we can move this like this, move this like that. Now to get what we started with, we can move. We have alternating dotted double bonds in a ring, and we can move it like that. Now the other one, as you can see, is another one involving you have a pi bond between two electronegative atoms. So we can move this have a positive charge there. Just like that. You can put in the arrows. First of all, you move it like this, and you get this. You move this like this. Notice that this is a lone pair next to a positive charge, so that's why you can get this. And after, you can always get back to where you started, and you're back to where you began. And then here we have a pi bond between two electronegative atoms. So we can have this like this, have a negative, positive, because you have your pi bonds there, and then you can move it again. Actually, this positive charge would have disappeared by now, because we now have a pi bond here. We have a positive charge like that. Then we can have another one. Have a positive charge here like that. Oh. So again, we have been looking at allylic lone pairs, allylic cation. So you can see these are all allylic. So we can actually move this. So the first thing we do is move it like this. This is a pi bond between two electronegative atoms. But here we have an allylic cation. So we can move this like this. Right, and then we can move this like this. We get this, and then we can move this like this. We get that, and of course we can always go back to where we started by simply going like this, and like this, and we are back to where we started from. Okay. Now this one is pretty interesting. It's kind of interesting. This one, as you can see here, is a lone pair next to a pi bond next to a positive charge. So we can actually move that. Okay, we can actually move that. And we'll get this. We have a positive charge here. And a lone pair there. Then we now have a lone pair next to a pi bond. An atom that bonds a pi bond. Can move that as well. So I have a negative charge here. And to get back to where we started, I'm going to show you how we're going to do that. So basically here we moved this to arrive at this. And then to arrive at the other one, we simply went like this and like that, and we got at that. Now if you want to get back to where you started, of course you have to go more hoops. But basically these are which will be the valid resonance forms here, because all the other ones will have formal charges other than positive 1 or negative 1, which will be kind of too high. We don't want those with formal charges of positive 2, negative 2. Those will be too high. Now here, as you can see, we can have a lone pair next to a pi bond, so we can delocalize that. And we get something like this. See, so now we have a positive charge here. Of course, we have a lone pair there, and then again you have a lone pair. Now you have a positive charge next to a pi bond, next to a lone pair next to an atom that bears a positive charge. So you can do that one again. You can delocalize that. And I'm going to show you what I mean by that, as you will see shortly. You can now have a triple bond. You have a positive charge on the nitrogen, and you now have a negative charge like that. You see? And then of course the next one is whereby you have a lone pair next to an atom that bears a pi bond. And so that one you can easily go one step further, and we get the hydrogen, the carbon connected to a double bond, but now this carbon bears a negative charge, and this is there's a positive charge, and this is now connected to the oxygen. Okay, right? And then what you can do with this now is, of course, if you go back, you go back to where you started. Yeah, but what we can do in the last step is that we can now get back to our starting point, and I'm going to show you how that happens. Now here, you want to go like this, and you want to go like this, and then you want to go like that, and then to get to the next one, you want to go like this. That's how you get to this one, and then to get to this one, you go like this and like this, and finally to get to from this one to get back to where you started, all you can simply do is just move this like this, and you're back to where you started. So you see, it's very important that you recognize patterns. If you don't recognize patterns, it will be difficult. So I hope this helps, and let me know if you have any other questions. Thank you.